Okay. Who's gonna start for?
Section 3, Basic Automatic Controls, Unit 15, Troubleshooting Basic Controls.
Uh-oh, what does that say?
Troubleshooting.
Troubleshooting, that's the exciting word, huh? Isn't that the word that you signed up for?
The word of the day.
Troubleshooting.
Objectives. After studying this unit, you should be able to describe and identify power and non-power consuming. Describe how a voltmeter is used to troubleshoot electrical circuits. Identify some typical problems in an electrical circuit.
Okay.
Continue. Describe how an ammeter is used to troubleshoot an electrical circuit. Describe how a voltmeter is used to troubleshoot an electrical circuit. Recognize the components in a heat-cool electrical circuit. Follow the sequence of electrical events in a heat-cool electrical circuit. Differentiate between a pictorial and line-to electrical wiring diagram.
Introduction to troubleshooting. Recognize the control and its purpose in the system. Controls are either electrical, mechanical, or both. Electrical devices are power-consuming devices use power. Power-passing devices pass power without consuming power themselves, ideally.
Okay, if we remember, we talked about these controls. They're not mysterious. Not mysterious. Okay, so you won't be going, oh, what manner of sorcery is this? Okay, so here is a circuit, right? 115 volts. Switch. Power consuming device. See, it says right there, power consuming device. Switch that passes power. Light and heat. Okay, you see that? Okay, check it out. Check it out. So if you're checking this circuit right here, see the circuit right here? We're gonna check it with our voltmeter. See it? So we're gonna go to neutral to high, right? 115 volts, we're reading on our meter, right? And we're gonna continue to read that all the way down this line because you're reading actually one line, right? See that? One line, one wire, right? Except when you get to up, right there. And open, it's open. So now you're not gonna read anything because it's open right there. See that? You guys understand that? You guys getting that? Yeah?
Troubleshooting complex circuits. Tips. Check the thermostat 0 volts from R to W. When there is a call for heat, the coil of the relay should be energized. Check the fan circuit. 0 volts from R to G when the coil is energized. Check the cooling circuit. 0 volts from R to Y when there is a call for cooling.
Okay, so what they're talking about is they're talking about these 4 terminals right here.
Hot, cold, fan, heat.
That's when they're saying R to G, R to W, or R to Y, right? So you're gonna check voltage between those terminals. What should you get between those terminals? What kind of voltage?
0.
Oh, yeah, 0. Makes sense.
0?
Not bad.
You missed.
You should have.
Yeah, it literally says 0 volts. Sorry, I skipped that.
What
It
happens
says
if we
0
have
volts.
24?
Your question again?
That's what I thought. What happens if you have 24 volts?
Electricity is passing through. No? Okay.
You know, that was a 50-50 shot.
That was a really good shot.
It means electricity is not passing through. Because the switch is open. Remember from last week that the thermostat is what? What?
Switch.
It's a switch. A bunch of different switches, right? Okay, so it's gonna pass power. So how we know when it's on, when it's open or closed? How we know when stuff's on or off? Huh? By checking what?
Front?
Yeah, checking across the terminals. It's gonna tell us whether the switch is open. Are these switches open or closed?
Close.
Closed. Wow. Wow. They're closed because you're not reading anything. You're not reading any voltage, right? You're reading a wire. You're only reading one wire. You're not reading any potential difference. Okay? Are you ready for this? Check it out. The transformer is 230 volts to 24 volts. Do you obviously see that right there? So it's a step up transformer or step down?
Step down.
Okay, there we go. You'll be learning things.
What?
Okay, so you're gonna come out of the transformer on R. You're gonna go through the thermostat, through the heat switch, the on-off switch, and go through the thermostat, the temperature sensing device and the thermostat, and you're gonna go out that thermostat on the white terminal, energizing the 24 volt relay coil. Okay? The heat relay. And back to the transformer. So it's complete circuit, right? Seen that? Seen that? Everybody seen that? That's one complete circuit. Okay, this one over here is just showing you that heat anticipator, how it's wired in the circuit. So same circuit, it's just showing that there's a heat anticipator in there. Okay? We cool? Cool? Good? Oh boy. Oh boy, it gets more complicated. Okay, so this dotted line right here is the thermostat. Right? Room thermostat. Room thermostat. Sorry, I was thinking of Stratocaster. It's a guitar.
Okay.
So again, we're coming from the transformer, coming out the transformer to the R terminal on the thermostat, going through the fan switch, and it looks like the fan switch is on, so it's coming out the G terminal into the indoor relay coil. Indoor fan relay, see that? And it's energizing on that circuit there. Nothing else is open down here, so we don't, that's the only circuit that's active. We getting this? We're checking this out, man?
Okay.
You feeling me? Oh, look, more complicated. Here we go. So, again, we're coming out of the transformer to the R terminal. See the R terminal right there? Can you see that? Going through the fan switch, it's no longer fan on, now it's fan auto. So we're gonna come straight down here, we're gonna take this road, it's just a road map, we're gonna take wherever we can go, we're gonna go, right? Oh look, we can come down through here, and we come through the cool switch, the mode selector switch on the thermostat, comes through the thermostat, there's a cool anticipator, it goes through the temperature sensing device inside the thermostat, and it goes out the yellow terminal and energizes the cooling relay coil, right?
Correct.
See that? Also makes another turn here, and it goes up goes back, goes through the fan switch, and it energizes the indoor fan relay coil. You seeing that? So that's what makes that fan turn on when the cooling turns on. Okay? Any questions?
So far.
Does anybody care?
Why?
Nobody cares.
We should be asking questions right now? That's what you wanna know?
You have any questions?
Oh, wait,
You
okay,
understand that?
So. Oh, wait, I was, see.
What? Is that only when
Wait.
it's on auto?
That's when it's on auto.
Other.
That's when the thermostat is on auto.
Is that G a switch or just?
That's the designation. It's coming out of the thermostat on G. It could be over here, could be a G over here,
Okay.
instead of over here, it doesn't really matter.
It doesn't matter, as long as it's just on there.
Yeah. Okay. You good? You like that?
If you ask questions, Steve, there you go.
Okay, so this is what happens in the cooling mode when the unit has cycled off. When it's satisfied its temperature, comes down through here, same circuit, right? Temperature has dropped and it's opened the cooling coil, and it's also opened the fan coil, so nothing's running here, except the cool anticipator. See those little lines right there?
Mm-hmm.
Those are heat. Those are
Okay.
heat lines.
Okay.
So it's generate a little bit of heat to throw that thermostat a little bit off, okay? We talked about that, right? You don't remember?
Not right now.
Why not right now?
Because he's
No, just cause it doesn't click a button in my head. You know what I'm saying? Oh, remember that. Troubleshooting the thermostat. Control voltage must be present in order for the thermostat to operate. Turn the fan switch to the on position. If it comes on, there is a low voltage present. If the fan does not operate, there may be a low voltage problem. Check voltage supply to the transformer primarily. Check voltage at the transformer secondary.
Okay, so all they're saying is you have to have control voltage, so that transformer has to be energized all the time.
Alright.
If you don't have that transformer energized, nothing's gonna happen. Right? Okay, so first thing I would do this all the time. In fact, I was gonna write a book about shortcuts like this, and this is just a shortcut. This is telling you, first thing you do, what's wrong with the unit? You don't know, customer's not around, what's going on with it? Where do you go? What do you do? Where do you start?
Go to the thermostat.
That's what it's saying, right?
Yeah.
Go into the thermostat, hit that fan switch. Does the fan come on? Yes.
Is it?
Yes?
Yes,
Then you
let's
know you
assume
have
yes.
control voltage.
Let's assume yes.
If the fan doesn't come on, then you know you have a problem with control voltage, or high voltage, either way. So all that's gonna do is turn on the fan switch in the position if it comes on, or if it doesn't come on, it's gonna give you, it's gonna take you to the high voltage or something else. So by process of elimination, all you're doing when you troubleshoot. Okay, you get that? You're just eliminating things that it can't be.
Yeah.
So if you go in there and check the thermostat, and you hear the fan come on, you're not gonna go check the transformer. Cause you already know it's good, it's running, it's got control voltage, right? So all you're doing is eliminating things that it can't be. Okay?
Makes sense.
It's not that difficult.
Yeah. There's no rocket
Once you
science.
understand the sequence operation of the system, yeah, no problem, no problem at all, right?
That's the goal here, right? So we can know the whole system. troubleshooting the thermostat continue. Can be removed from the subbase. Installated jumpers between R and G. The fan should come on. Install insulators jumpers between R and W. Heat should come on. Install installated jumpers between R and Y. The cooling should come on. Defective if circuit operates with jumpers, not thermostat.
Okay, so this is, when you think about it, this is pretty simple. I got a visual aid for you. Maybe. Here we go. Okay, so this is the thermostat subbase. You see that? The thermostat subbase. This goes on the wall.
Okay.
This is the thermostat. This goes on the subbase.
This is the old modern ones.
Okay. It goes on the subbase. It goes this way.
Come on, Steve. I thought you should know this.
Okay, so what they're talking about is take off the thermostat. There's a cover that goes on here too, so there's actually 3 pieces. So the cover is just a cover.
Okay.
So what they're saying is take off this thermostat's removed, can be removed from the subbase.
Okay.
Okay?
Okay.
And what they're doing is these terminals right here, where it says G, R, Y,
W.
W, you can jump those to make the system do what you want it to do. Just
Okay.
like this thing does. Because the switches are, the contacts are
But
in
you
this
do
side.
it like instantly.
So you do it on the wall and you jump the unit, bypassing this. If it doesn't work with this on it, and you take this off and you jump it, and it works, guess what?
It's that. That's what's
It's
that.
a bag. That's pretty simple, right?
Simple,
It works
yes,
with it,
yes.
works with it. Works with it, works
Without
not
it.
with it. Right? So that's all they're saying on that. You wanna have, here. There's some, hands-on. Okay, are we good?
So far, so good. So oh wait, question. So if I put them like on, should the system turn on right away or like right away?
Yeah. Yeah.
I know it's just a dumb question. I'm just saying if there's like, what if there's a lag?
No, there's not gonna be a lag.
No,
It is
shouldn't.
on or
They
off.
shouldn't be.
Either it's gonna work or it isn't.
Okay
So
then.
you're eliminating any potential right there by removing the subbase. Or removing the thermostat from the subbase, let's say. Okay, so, yeah, I lost my train of thought, so.
Sure.
Okay, so this is what they're doing, this is a cartoon of what they just talked about. You got a jumper on the R terminal, and you're gonna jump each one of these components, the white, the yellow, or the green with the one terminal, you're just gonna jumper it, right? And you're gonna listen for the systems to come on. You see that?
Okay.
Okay?
Troubleshooting the thermostat. Continue. On a call for heat, power is passed to the heating relays. On electric heating systems, the fan will also be energized on a call for heat. On a call for cooling, the following system components are controlled: compressor, condenser, fan motor, evaporator, fan motor.
Okay. So what they're saying, let me draw this picture. Making noise.
Yeah, that's what I said.
Yeah. What's bothering you, huh?
Yeah, it was passing me. It was distracting me.
Okay, so what they're saying is R is, what's R? Hot?
Hot, yeah.
Hot.
Caliente.
Okay, then you got R. Oh, now you got, I
Why?
already got R.
Your Y? Or G? Or your
We got G, Y,
W?
and W. W. So what happens when it calls for, when the thermostat calls for cooling,
E?
R and G make, and R and Y make. Okay, I said that backwards?
Yes.
Confused you.
Yeah, you did confuse me. I was like, why he's going to the Y?
So this is what happens inside the thermostat. It makes 3 terminals
Uh-huh.
for cooling, okay? It's talking about electric heat. Then electric heat is gonna do this. R to G and R to W. That's electric heat. Gas heat is not gonna bring on the fan. Gas heat is just gonna bring on the burner, the furnace. The fan will operate on another circuit,
Okay.
okay? And then when we bring on, just the fan, that's what happens inside the thermostat, is those connections are made. Okay? You understand how thermostat works now? Good.
Troubleshooting the thermostat continued. The compressor and condenser fan and motor are wired in parallel, controlled by the Y terminal, which passes power to the contactor. Contacts close and energize the compressor and condenser fans. The indoor fan will operate continuously when the fan switches is on the on position. It will operate only when the compressor is operating and the fan switch is in the on position.
Okay, so the compressor and condenser fan motor are wired in parallel, we got that. Controlled by the Y terminal. Right? The indoor fan is gonna, you guys already know this. Anybody have a thermostat at home?
Yeah.
Yeah?
I have like one of those old school ones.
So we know when the fan is on the on position, the fan just never shuts off.
Yeah.
Okay. That's all it's saying.
Oh, you just hear it.
Why do I got bad connection here? What's going on here?
I think you do have a bad connection. Yeah, you have it too static.
Okay. So that's what that's all about, that's what they're saying there.
Troubleshooting amps and low voltage circuits. Transformers are rated in volt amperes. VA. VA rating can be used to determine if the control circuit is drawing too much current. Max ampage VA rating / secondary voltage. A 40 VA transformer with a secondary voltage can handle the max current of 1.67 amps amperage.
Amps.
Amps. I said amps. Obviously. Maximum amperage equals 40 over 24 equals to 1.67.
Okay, you understand that?
No.
Okay, so instead of using a 40 amp,
Uh-huh.
we use a 75 VA.
74.
So we got a 75 VA transformer,
Okay.
75. Okay, so what is VA?
Voltage per amperage.
Watts.
Watts.
Volts times amps.
Oh,
Right.
I always forget it's when it's a variable.
So if it's watts, then we can take and figure out what the amperage is by looking at the wheel, right?
So volts
Amps.
times.
We're looking for amps, so we have P and we have E, right?
Yeah.
Okay, what's our E?
40.
24.
24. Oh, 24. Sorry.
24, so we have 24 volts and 75 watts, and what does that work out to?
Oh,
Around three.
1.67. No. Okay. I'm just assuming. I thought that's what.
3.125.
3.125.
3.125. That's the maximum amp draw that transformer should take,
Should
or should be drawing in that control circuit. So if you're doing more than that, guess what? You got a problem somewhere, okay? So that's also how you're gonna size your fuse too. So you put a 3 amp fuse in there and go for it,
Okay.
okay? I like having a smart board. I mean,
Do you brag to the other teachers about it?
huh?
Do you brag to the other teachers about it?
Uh-huh.
Yeah, you're like, I got a smart board. What about you?
They got TV sets up here.
Lame. Can't even touch them.
Okay, so what did you say? What did you say?
Troubleshooting amperage and low voltage circuits. Using a clamp-on amper, coil a jumper wire around the jaws of the meter 10 times. Place the jumper in series with the circuit being checked. Divide the amper reading by 10. Actual circuit amperage should be lower than the calculated maximum circuit amperage. Electronic clamp-on meters can often be used instead.
Okay, so what happens when we coil a conductor? We take a conductor and we put it in a coil. It's got power going through it. It's got amperage going through it.
Okay.
And what happens? What happens? Huh? It increases the magnetic field.
Uh-huh.
I know it's Monday, but yeah.
Might just turn it off, Steve.
Okay, the same way you're gonna coil a conductor around the jaws of a clamp meter, an amp, a clamp on, and it's gonna intensify the reading that is going through that wire. Alright, check it out. Okay, so if it says 10 times, says divide the reading by 10, if you have 10 turns, but really if you have 8 turns, you divide it by 8.
Okay, so you divide by the turns.
How many turns, yeah. And that's gonna give you the 8 times as many or 10 times as many amps as what you're actually reading. Okay, you guys won't have to worry about that because your meter is digital and it'll read below 1 amp. Back in the day when I was doing this, they didn't have digital meters.
They say good luck.
That's how that's what we had to do, is we had to wrap it 10 times around the jaws to get the actual current draw through that circuit. Okay, and why would we need to get the current drawn through that control circuit? Remember? Remember?
I feel like he remembers what happened.
Yeah, I feel like you should know.
I think we just talked about transformers that read the voltage.
For one, you're gonna check and see if it's drawing too many amps. Okay, you're gonna check the amp draw and make sure you're under the maximum, and that you're gonna have to figure out, like we just did. Get the VA and divide it by the voltage. Okay? Another reason you're gonna have to do that is because you're gonna need to set that heat anticipator. Okay? But you guys won't have to worry about it as long as you stick with a digital amp meter. Okay?
So
Got that?
this is in case just our boss just like throws us.
Well, you might have a situation where, that question may come up in an interview.
Okay. That makes sense. What?
Okay, so here's a cartoon of it. You have the high voltage section. You have compressor, outdoor fan motor, electric heater, indoor fan motor, and all of them are controlled by these contacts, right? Right now it's showing that the contacts are closed to the compressor and outdoor fan motor. Isn't that amazing?
Yep.
Okay, so what they're doing, they're showing right here is how to hook up that loop pin wrap coil
Okay.
between the R and the rest of the control circuit. And so they're right on the red wire, and they're just checking the amp draw of each component as they turn the components on.
I think I'm getting excited too.
Huh?
Nothing.
Are you doing that?
I think I am. I feel like I am.
Okay.
Troubleshooting amperage in low voltage circuits continues. Power consuming devices need to have the proper voltage supplied to them. The relays holding coil is rated at 24 volts, there should be 24 volts applied to the coil. If there is a reading of 0 volts across the coil, the problem is likely not the coil. If there is a reading of 24 volts across the coil and the relay contacts do not switch position, the coil is affected.
Okay, so here's another common sense thing. You should have the proper voltage across the coil in order for it to operate. If there's a reading across the coil, there's a 0 reading, that means you're not getting the proper voltage, right? If 0, if it needs 24 and you're getting 0, that's a problem, right?
Big problem.
Okay, if you're reading 24 volts across that, on any component that you're gonna troubleshoot, if you got the proper voltage and you see the voltage on that component with your meter, and that component's not doing what it's supposed to be doing, the component's bad. I mean, it's just simple. You just gotta, you see, if you got a relay and you got 24 volts across the coil and it's not turning, it's not clicking, then it's bad. You've got a motor, you got voltage across that motor, and the motor's not going around and around like it's supposed to, it's a bad motor. Okay? It's pretty simple really when you go to troubleshoot. Just things that I've heard throughout the years that make it sense, make it simple. Because we're gonna make it as simple as possible.
I feel like we're trying to make it rocket science in our head, but it's just like, you know,
Yeah, everybody
just
wants it,
learning how to
everybody
drive.
wants that,
Yeah.
the brotherhood. The brotherhood wants it difficult, because they don't want everybody doing it.
You think everybody can do it?
Huh?
You think everybody can do it?
I mean, Steve said
It's
that.
simple, it's simple as long as you understand the principles.
Steve
Right?
said he believes everybody should know a little bit of this.
Yeah. Everybody should know Ohm's law at least.
See,
Everybody should know that.
I remember him talking about that the other day because of his podcast, or his radio station. Sorry, the radio station.
Oh. Okay, so guess what? We're gonna keep it simple, right? Does that look pretty simple?
No.
No?
But I
Okay.
bet it is.
So first thing, when you're trying to look,
I can see.
you can't see?
I'm back there. It's too complicated.
Okay. Do you wanna sit here?
Oh, this one.
Okay, so the first thing we do on this circuit is we're gonna look at the two parts of that circuit. And the two parts are,
Heating cool. Two parts are.
two parts. High and low voltage, right? So, we're gonna look at where is that transformer at? Can you find it?
Middle.
Right where?
Right way.
You guys know what a transformer looks like?
Yeah.
It's like it's right there at the top right.
Huh? It's on your handout, schematic handout,
Yeah, top right over there is black. Top right square.
right here,
Black.
right? Transformer. So everything on this side of the transformer is all high voltage. When power comes in, these are all the high voltage components. Anything below that is all low voltage. So once you determine whether it's a low voltage problem or a high voltage problem, you're gonna start, first thing you're gonna do is find out, well, what's all in low voltage? Just check all this stuff and let's find out if all those components all those switches are open, or the ones that are closed, that are supposed to be closed, and the ones that are open. Let's see. So that's what you're gonna do. So when you look at it, you can't look at the whole thing and say, what am I looking at? Cause that's, yeah. Cause if you ask yourself, what am I looking at, then you've lost. You've lost the battle right there. So you gotta break it, you gotta make it simple, okay? So low voltage problem, high voltage problem,
Okay.
okay? Here's another one. Where's that transformer at?
Transformer.
I feel like you should know that.
Yes, I feel like I should know that. Can't freaking see. Everything's small.
It's right in the middle.
No. Is it?
Right in the middle.
Oh, yeah.
Right in the middle. Oh, yeah.
Oh, yeah,
It's
right
just
there.
so big. It's
Right there in the middle.
so big. I just like ignored
We're
it.
looking for a smaller one.
Yeah, I
It's
was looking for something
it's
smaller like the other one.
It says primary and
Secondary.
secondary, right? So here's your common wire and here's your 24-volt hot. So this is the red wire. It's coming down here. And you know that wherever it's gonna end up here at this red terminal, because all these little things right here, those are wire nuts. So that's saying that this is going to the thermostat. That's field wiring.
Okay.
So here's all your colors on your thermostat. You know that that's all on the low voltage side. So if you have a low voltage problem, then you're gonna go from there. If you got a high voltage problem,
Up
it'll be
there.
up on the top here.
Okay.
It's not necessarily gonna be up on top and bottom. It's gonna be separated by the transformer itself.
You just gotta figure out what transformer it's saying.
Yeah.
If it's high or
High.
low on the bottom.
And again, the PowerPoint started out with knowing what those controls look like and identifying them is what's gonna help you, because you're gonna go, oh, look, that switch right there might be open. Well, what is that switch? Huh?
That one.
That one.
Can't read it.
It looks like a pressure switch.
Yeah.
It's like a low pressure switch, right?
Yeah.
Okay, you gotta know what that looks like in order to test it, right? Okay. Okay, so we have a long ways to go as far as identifying all the parts. So once you identify all the parts, and you got that down, troubleshooting shouldn't be any problem. As long as you follow along and how the sequence of, current is gonna flow through the circuit.
Troubleshooting voltage in the low voltage circuit continued. Remove thermostat from the sub-base and check the voltage circuits for reading of 24 volts between R hot terminal and the Y cooling terminal. Reading of 24 volts between the R hot terminal and the W heating terminal. Reading of 24 volts between the R hot terminal and the G indoor fan terminal.
Okay, so this is what we were talking about before. So you take this thing off, you take this thermostat off of this subbase, and you got the terminals exposed. Right there, right?
Okay.
See those terminals are exposed? You're gonna check between R and W, R and Y, and R and G, right? Okay. On this particular thermostat, that means that when the cover is on, that means the switches are
Switches are.
they're in the circuit.
Uh-huh.
So you can turn it on and off from the thermostat.
Okay.
Some thermostats, you don't have to take this off.
Okay.
Some thermostats, you can see all the connections through the thermostat itself, right on the subbase. Those digital thermostats sometimes are like that. So it depends if these are active or not active. So if you have the thermostat on there, let's put this on here. You have it all connected and you can reach those terminals with the thermostat on, then you can tell if the switches are actually open or closed, and you can turn the switches on, right here, see?
Oh, okay.
And do I got it? Do I got it? Okay, the switch closed, open, whatever, okay?
So this is fabricated manually, all the components are put on it manually, on the base?
Some of them are, but if the switches are on the subbase itself, then you can't really check, because it's also gotta go through the contacts in here. So it's all, once this is all put together, it makes connections in between the subbase and the thermostat itself, so, best way to do is just take the whole thing off, disconnect it, put it back together, and check the terminals and flip the switches. So take it out of the circuit and check it with ohms. You know, ohm. You just check continuity through that.
Troubleshooting electrical switches and loads. Switches are wired in series with power consuming devices. All of the switches must be closed for the load to operate. Switches in parallel provide alternative control sequence for the load. If there is a line voltage supplied to the circuit, there will be a line voltage across an open switch.
Okay. So the bottom statement right here, if there is line voltage supplied to the circuit, there will be line voltage across an open switch. So that's gonna tell you if the switch is open or closed. Right? Switches in parallel, I think we covered that last week, remember? Alternate, for alternate control in different locations, you can have a parallel switch.
Yeah.
And all switches must be closed for the load to operate. Okay, so all the switches are gonna be closed. They must be closed. We go back to the circuits, right? All these switches need to be closed if they're normally closed. So you're gonna know that by the schematic and by the drawing, which ones are supposed to be closed for normal operation. Okay? So you'll be able to see if there's one, you can make an assumption that these are supposed to be closed, but there could be one that's open.
Correct.
So you're gonna have to check each one, find out why a certain thing isn't working right. Okay. What is that? Some facts. Let's do some facts. You want some facts?
Yeah.
Do some facts.
Troubleshooting electrical switches and loads continued, some facts. There will be 0 volts across a closed switch. The voltage reading across the windings of a de-energized motor will be 0 volts. An ohm meter can be used to check switches and loads if all power or wires are disconnected. Infinite resistance reading indicates an open circuit. Never use an ohm meter on energized circuits.
Okay. So, I like this one. If the voltage reading across the windings of a de-energized motor will be 0 volts. That means it's de-energized.
So it's not working.
Like I said before, you can check an ohm meter, you can take an ohm meter and check the switches, see if they're closed or open, but you have to have the power off when you do that.
Okay.
Okay.
Logical sense.
And any switch that's closed, you're gonna read 0 volts across. Right, it's pretty.
Correct.
pretty
It's
simple,
one
right?
wire, you're not reading the difference.
Yeah, you're just reading one wire. Okay, break down.
So simple.
Break down. Break down.